Well, I think we're going to go ahead and get started. Good morning. My name is Phil Cates. I am a extension educator located in Lapeer, Michigan. I cover most of the thumb, and I have a statewide appointment for forages that I work with quite a bit. And this morning, I'm pleased to be able to be your host instead of the co-host for Virtual Breakfast. We're getting close to the end this year. So what I'm going to do is I'm going to introduce Dr. Ehsan Ghane. Ehsan is our drainage extension specialist, and I'm looking forward to learning much more about drainage, and I expect that he's got lots to share. So I'm going to stop sharing and invite Ehsan to open his screen and share with us.
All right. Good morning, everyone. Thank you for joining us today. So we're going to be talking a little bit about water, something we're really excited about, talking about water. Water comes with drainage. So let's um, get going with the topic here. So the topic, I want to go through a tip for maximizing drainage system efficiency. This is a beautiful photo of our planet Earth. And you have experienced a climate disruption, of course. In this case, I'm talking about those heavy rainfalls that we get during the year, basically, and they've become more frequent. And on the opposite side of that, we were seeing that um, in some cases, in some years, we get these drought periods during the summer growing season, and we're seeing some of the rainfall shift from the growing season into the non-growing season. So this heavy rainfall means a lot of water, and another climate disruption. Another one is delayed planting. So these are climate disruptions that causes problems, yield loss, damage, insurance problems. So it causes a lot of problems. So let's see, um, and when you're talking about this climate disruption and all of this water, what comes to your mind? Of course, tile pipe comes to your mind. This is the first thing that comes to our mind because we think that we gotta put more tile in the ground, or if the field is undrained, we just put the tile in for the first time in the ground. That's what comes to mind when you're thinking about all of this water, extra water that we want to remove and get on with our field operations. So, in some cases, as I mentioned, the field is undrained, you put the tile in, or you already have drainage and you want to go narrow spacing. So, this is another thing that comes to our mind too, that you already have a drainage tile system, and you're thinking that I may need to go narrower now, or we call this splitting the lateral spacing, really splitting. So this could be also all of those, the climate disruption, all of that extra water could be a trigger for this going thinking about this narrow spacing. But we need to think about this very carefully at this point because just splitting lateral spacing, going narrow is not gonna get you, may not get you faster water removal. There is more to it, which I want to explain here today. That's my really objective today to explain that concept here. So, for even before thinking about the narrow spacing, my suggestion for you is to take a look at the drain spacing tool. This is a tool that helps you come up with a drain spacing that maximizes economic return on investment or profit. I'm gonna leave this QR code. Actually, the app, if you would not be able to use it on your phone easily, it may work, but we use it on our desktop. So to show you, to get to the site, just search for MSU drainage. If you just do a search for MSU drainage, the first thing that comes, any search engine, the first search that comes, it would be the MSU Michigan State Biosystem and Ag Engineering Drainage website. This is an MSU drainage website. So all you have to do is to do MSU space drainage. And your first search result would be a drainage website, which is Michigan State's drainage website. So to get to the tool, if you're wondering where that tool is, you hit tools on the top of the page. Then next screen that opens up, it's called Drain Spacing Tool. When you click on that, you're taking to the tool, and you can, I'm gonna zoom into Michigan, my favorite place, and let's just take a random field, and then you draw boundary in the area, and then you hit calculate. So that's basically, this is very, very in nutshell. There are videos of me giving training of this. I invite you to check those out. But let's let me show you the output page I have until, so this is going to be processing the data. Until that gets going, I'm going to show you another site that I zoomed in. So for this case, it's showing 131 feet spacing. And so there are other data that you can get. So let's go back. So this is a side. So let's go back to the talk here that we're talking about narrower spacing. So like I said, if you go narrower spacing, it doesn't necessarily mean that you're going to get faster removal. There's more to it, and I'm going to be explaining that. So basically, this is the water component of a farm. Once water arrives in the form of precipitation on the form of precipitation on the ground, you see this precipitation coming down on the ground, it falls on the ground and it infiltrates, and then it moves through the soil, it finds its way towards the pipe, the tile pipe. And then through that, it finds its way towards the outlet, and that's what we call drainage discharge. So really, this is the journey of water when it comes down in the form of rain, and then it ends up in the outlet of the drainage system. This is the journey. So let's look at that a little bit more closer. So in that journey that water took, coming down on the from precipitation going out from the outlet, water has to move through the soil into the drainage pipe. And this is a graph that shows that. So water comes down from the moment water hits the soil, water moves through the soil, finds its way through the pores, and it finds its way inside the pipe. So this is water movement through the soil into the pipe. And we call this drainage intensity. It's basically how intense water can leave the field. Really, that's what it means. Drainage intensity is a very important term. It's a relatively new term, and I want to discuss that with you today. So this is the first part of that journey. The second part is that once water gets into the pipe, then it's going to have to find its way through all of the drainage pipe network toward the outlet. And you can see here in this diagram here. So as water moves through the pipes, we call this concept drainage coefficient. So really, if you look at these two, water makes a journey through these two parts, and these are very, very important if you want to maximize your drainage efficiency. I'm going to show you how. So really, in this case, if these pipes on the right side, which are the pipes, really the main pipes, if those are too small, water is going to enter the pipe from the soil faster than the pipe, that main pipe that can carry away. So let me demonstrate that in another um, diagram here. So you see, this is the same drainage system, but we're looking at it from a different angle now. And in this case, again, these are the pipes, lateral drain pipes. So remember, the first part of the journey was water moving from this area, from the soil, moving through the soil into the pipe. That's we call drainage intensity, and that's how intense water can move through the soil, really. And then there's other pipes we call the main collector pipes. Those collect the water and convey and actually transfer or transport the water to the outlet. So as I mentioned in the previous slide, if the diameter of this one is too small, you could be spending $2,000 per acre splitting lateral. It's not going to do any use. It's going to have a minimal effect. You will be wasting a lot of money if you've done that, or if you're thinking of doing this. It's not only that. So because in that case, water is going to enter the pipe, enter the main faster than the main can carry away, really. So, and we have data. that we see yield loss in those scenarios. My
1,050.
my colleague from Iowa State also has data for yield loss, and through the you would be able to watch the videos online for that. So those are yield loss, so is important. When I say yield loss, it doesn't mean that it's not going to be germinating. I mean yield loss compared to the optimum condition where you're going to maximize. So it's going to be a little bit lower in those cases. So if we have a video, this is the QR. If you want to scan this, this is going to take you to a video on YouTube. So you will be able to watch that on your phone. I'm going to give you, if you want to scan this. So in the next slide, I'm going to briefly show you and demonstrate why this is so important. Okay. So check this out. So we got, I got two barrels here. These are farms. Assume these are farms. The one on the left is your farm. The one on the right is your neighbor's farm. And both the farms, both you and your neighbor have the same soil, the same drain spacing, the same drain depth. Everything's the same. The only difference is that drainage coefficient that I told you about, that the size of the pipe that carries water away, on your farm, you use half an inch per day. That's the rate of water leaving to size that main pipe that carries the water away. But the neighbor used 4/10 of an inch per day. So let's see what happens when a rain comes and your systems are gonna be draining the field. Let's see what happens. So take a look at this. Clearly, the one your farm is draining a lot better than the neighbor's farm. You see that? It's draining a lot better. And the reason is in this case is that in this system that you were looking at, your farm and neighbor's farm both have drainage intensity of half an inch per day. It means that water, once it lands in the form of precipitation and moves through the soil until it gets into the pipe, it moves at half an inch per day. That's how fast it can go. Your both fields were the same, but you use the drainage coefficient that matches the drainage intensity, and you were able to drain that field a lot faster than the neighbors. The neighbors use zero point 0.4 inch per day. So this is a very important concept. It's a new, relatively new concept. We've only been teaching this for 2 years in Michigan, and there are fields out there that have this issue because, like I mentioned, it's a relatively new concept. We've only been teaching it 2 years. So, and some may be unaware of this, and some fields are likely going to have this issue. Some fields. So you may ask, now that we watch this, you may ask now that say, okay, now that I know this drainage intensity is a very important term. So drainage intensity is like um, your car's mileage, fuel efficiency, 20 miles per gallon. This is something that you should be able to calculate for your own drainage system. It's very important. So how do you get this? How do you know what drainage intensity is on your own farm? Because that's important, right? You got to know how fast water can move through the soil into your pipe, into your drainage pipe. So there's a drainage calculator here. Again, let me show you on the website how to get there. So again, do MSU drainage search, and then you'll get to the drainage intensity. And then you click on tools, and then you hit drainage intensity. And this is a very simple tool calculator that would get you the drainage intensity for your field. So you enter your drain spacing, your drain depth. These you know those two. The ones that may be a little bit challenging will be depth to restrictive layer. You may also know this. If you don't, then you hover over the question mark and then you go to that tool that I showed you. The reason I showed you, I had the main reason actually I showed you this was that if you hovered over this and zoom in and draw a boundary in the output page of the drain spacing tool, you will be able to get that depth restrictive layer. So in this case, 10 feet on this farm. So I can just enter 10 here. And then the other one that's a little bit difficult to get is the saturated hydraulic conductivity. This is basically how fast really is a measure of how fast water moves through the soil, and the soil can transmit water in that. So in this case, it's about 5.6 inches per hour. This is a fast, very fast. So in let's say I just entered 5.6, but in this case, this soil would be looking at probably 60 feet spacing. So if I hit calculate, I'm getting about 3 inches per day drainage intensity because the soil has a very fast drainage um, water transmissibility. So here I'm going to be getting a drainage intensity. So this is how you can get that. It's very important to know this because once you know this, then the next step is that you can take a look at your, if you have an existing drainage system, go look at your document that the drainage contractor gave you, look at those numbers to see if you see what drainage coefficient they used to size the main pipe that I showed you. If it's a number that's less than the drainage intensity, plus or minus 10%, of course, these are agricultural calculations. We always have a margin of error. So 10% plus or minus, if you're lower than that, then you need to make a phone call just to do more investigation about that. And if your drainage coefficient is higher than drainage intensity, you're in good shape. You are not restricting that. But there are cases that I have seen that this has happened, and there are fields out there that this is happening. And this was the QR code for the. So take a look at that. It's not about having so many years of experience. This is, like I mentioned, this is a relatively new concept. Only 2 years of being teaching this. And if you want to maximize your drainage in performance, you got to make sure that you're not creating that bottleneck like I showed you in the video. You're welcome to check that video out. And if you're thinking about reading more about this topic and other topics that could relate to underperformance and reduce the efficiency of the drainage system, again, that website that I showed you, the drainage website would take you to a link, conventional drainage, and then there's a drainage underperformance that you click and you can read a lot about these, many different things, different topics. But one of them that I just wanted to briefly mention is that drainage has many enemies. One of them is soil compaction. If you have soil compaction, that drainage is not going to work well. You want to maximize that, and you'll be looking at soil health practices and also breaking up those compactions and also prevent detraction moving forward over the long term with soil health. So to finish, I would I would I would say here that we have a field day next Monday, September 9. This is a mold drains field day. This is a cheap alternative to subsurface tile drainage, which I was talking about earlier. It's a budget-friendly drainage system. So we're having a field day. If you're interested in that, um, you would be able to find information about that on that website. If you go to, again, MSU Drainage, if you go to the homepage, the news and events, on the news and events box, you'll find the information about the mold drains and the location of where this is on September 9. There, I put a link here. If you click on the link, you'll be able to go to that location. The second event we have coming up is drainage workshop, where we teach how to maximize drainage performance, and we teach conservation drainage practices, including controlled drainage. That's coming up March 4th to 6th, 2025. If you're interested, check the website out or contact me. I'll be happy to answer questions.
And with that, we're going to have some questions and answers. Ehsan, there is a question that came in for you, and it is, how does compaction affect saturated hydraulic conductivity?
That's a good question. Compaction really affects infiltration. Infiltration is when water moves from a ponding level on the soil into the soil. It affects the infiltration. It also affects saturated conductivity if the compaction is actually within the soil profile. And there are cases that happens with tillage instruments that the compaction layer could be a few inches below the soil surface. So it affects it by reducing it, really. The answer would be How does compaction affect saturated conductivity? It reduces that. And when it reduced, that value that we showed you, inches per hour, that's the unit, inches per hour. That's how fast it's moving. And it's gonna go down. And if that slows down, it's gonna slow down the drainage intensity. And drainage intensity is the key property of the drainage system, like I mentioned. It's one of the most, it's like how many acres you have, what equipment you have. This is very important. It's a new concept and it's very important. And recently started to teach this concept of drainage intensity. So I invite everybody to check that out on their farm and see what the drainage intensity is and find out what the drainage coefficient was to size the main. Because this is a new concept. Like I mentioned, I work with lots of excellent drainage contractors with Michigan and Leica. This is a new concept. So it's only been taught 2 years. So there are some fields out there that will have this condition that is not maximized. I would take a look at that drainage intensity for your field. And if you're thinking of splitting the lateral spacing, like I mentioned, if you split the lateral spacing and then that main collector that carries water away is about the same size or it is not sized properly, then you will be in that condition of not having a maximized drainage system. It's very important. It's more important than we think. Like I mentioned, it's a recent concept.
Ehsan, I have a question for you that producers often ask me, and it is how much water is enough removal versus too much removal? And how do you, I know you have a tool and a model to help us with that, but how would you explain that to a producer?
It's very complicated because there's multiple sides of the balance in the balance equation we're looking at. There's a side for crop production side that's the main driver of the decision of the landowner, the producer. That's kind of the leading one. And also on the other side becomes the water quality side. So I saw a comment in the chat that related to this question is drainage intensity would also give insight into nitrate and also phosphorus leaving and ending up in the lakes. So it is. That's correct. That's a very good comment there from Dale. And it is an insight. It gives us insight. The higher drainage intensity, the greater the chance that phosphorus is going to end up downstream. So because it's now moving more water faster, and it's faster, right? That inches, it could have been quarter of an inch. Now it's like half an inch per day. So it speeds up, means that there's a chance of the nutrients leaching is going to be faster. That's why we need water management. I've explained that in my talks. Water management is where you actually manage the amount of drainage depending on where you are in the season. So really how much drainage is enough, really we go to the tools because it really depends on where you are because every location gets an average long-term precipitation that affects the design of the drainage system. So where you are, is it in the thumb, southeast, or southwest? It depends on the soil. It really depends on the soil properties, the saturated conductivity, depth to restrictive layer. It really economics too. How much is the pipe material plastic today? And also the installation cost today and how much it's going to change. So it's complicated. That's why the tool takes in all of those really. So there really is a balance. And I've gotten calls that some systems that go in are overkill. They go just too narrow and the tool shows way higher and the soil just doesn't need that. And when they go that narrow, that main pipe that carries the water away, it's a bottleneck. So spending about $2,000 per acre, they could have spent like half of that, gotten the same results. But so it's a very, very important decision. It's extremely important. I want to emphasize that for the audience. It's very important. It's new, and I suggest everybody check the drainage intensity and get a number and get an understanding of what their field is doing. What is their It's like the horsepower of their tractor. It's important to know how fast water leaves from that drainage system. It's an important property.
Okay, thank you. I want to open it up to our other specialists that may have something to share this morning. And uh, is there anything from our other specialists this morning? Because I know that Jeff has a class this morning and will not be able to stay an extended period of time here too. So if there are any weather questions, anyone have anything to share? Our other
Hey,
specialists.
hey, Phil. This is Marty.
Marty.
I think just a note for corn silage. With the cooler conditions, tar spot is starting to pick up in some areas. So just being mindful of rapid dry down if you have significant tar spot in your fields. So just being out, keeping an eye on that. I think that's one of the important things at this point.
Okay, thank you, Marty.
That's all I have. Thanks.
Anyone else have anything to share? Hearing nothing, and I'm going to say thank you so much, Ehsan. Thank you so much, Jeff, for your excellent presentations this morning. Thank you, everyone, for participating in the virtual breakfast. We will see you next week. Until then, enjoy the weekend and have a great week.